Hi, it's Kevin here. Today we are going to start this 240 volt 3 horsepower motor with that jerry-rigged contraption. And we'll see if it works. First we need to take a look at some math, so let's pop upstairs and head to the whiteboard. Let's think about how we start a motor. Here's a simple circuit diagram. We have a 240 volt supply, so here in Canada it's two loads. We have load 1 and load 2, and together they're 240 volts apart. So we could just throw a switch and instantly connect both of those to the motor, and we would instantly have 240 volts across the motor. But the problem is the motor doesn't have a lot of resistance. When I went out and measured the resistance for the motor, I got R is equal to about 1 ohm. And since V equals IR, that means I is equal to V over R, and I is equal to 240 volts divided by 1 ohm, and that equals 240 amps. So instantaneously, there's a really good chance we're going to fry the windings on the motor. Now once the current gets going, the motor itself, it has not capacitance, it has inductance. Once the motor gets going and things start spinning, the inductance of the motor produces resistance, so now we go down to the normal current of about 8 amps for that particular motor. But for that first instant, there's this massive inrush of current, and that's the thing we need to worry about when we're starting a motor. So how do we do it? Well, a technique that was used a long time ago, back in the early 1900s, was to build in a resistor. So let's put a resistor in here and see what we can do. So we could do this. Put a resistor on that side. Put a resistor on that side, and we'll replace that and put a switch here. And the resistor that I pick, can't see it, there we go, is a 120 volt, 150 watt light bulb. So this should flow about 1 amp. One of these. We've got 2 of these. One on each side because I like things that are symmetric. So the way we start the motor now is we first throw the primary on-off switch. We'll keep this guy open, and the current flows through our light bulb or through our resistor, and that only allows 1 amp or 1 and a bit amps to go through. Hopefully that's enough current to start the motor going, make it spin. And then as it spins, the motor as it develops more resistance, that means it takes more voltage drop across it, and that reduces the current. So we should see the light bulb go from full brightness, and then it becomes dim. The motor hopefully gets close to full speed, and then when it's at nearly full speed, then we can throw the secondary switch and just short out the light bulbs. Now the light bulbs don't do anything. And we send full voltage and now we send full voltage to the motor. And this idea was used about 100 years ago for starting electric motors, and that's what we're going to try in a few minutes. Let's see if it works. So what is involved with this jerry-rigged contraption? Well, this is our resistive starting circuit, so I'll walk through what we got. First, we have the breaker box. So this is a 15 amp, because I'm only using 14 gauge wire, so it's only good for 15 amps. So this is the overload protection. Next is the primary starting switch. So this turns on the power for the entire circuit. I got a little clamp-on ammeter here. Hopefully we can measure the actual current going through this. These are two light bulbs, are the two resistances that we have in parallel with the secondary starting switch. So what we're going to do is I'll turn on the breaker to send power to this. Then I'll turn on the primary starting switch. We will see the two light bulbs glow nice and bright because they should draw about 1 amp, so 150 watt. And the motor should start spinning up. And as the motor picks up speed, it will create more and more resistance, so the light should get dimmer. And then once it reaches steady state, I will throw the secondary switch, will go to full power, or full voltage to the motor. Let's see if this works, because this is the maiden run. Step 1, power. Power is good. Step 2, primary switch. Step 2 did not work. We're going to try this again. Okay, we're going to try it again. The problem was there was a loose connection on my resistor number 2, the second light bulb. So we're going to try it again. Go through the same sequence. Breaker on. Looks good. Now I'll go to main switch. We should see the lights turn on and the motor spin up. The lights turned on. The motor is not spinning up. I don't think we have enough current to get this thing going. That is too bad. That did not work. Let's just throw the switch. Well, that worked. But I don't want to do that too many times. Actually, I do want to do that too many times. I'm going to see if I can measure the peak current. No, couldn't measure the peak current. I measured about 9 amps, 9 or 10. Right now it's drawing 3.7, so yeah, our little 1 amp max would not be enough to spin that little guy up. So, that answered that question. So if I'm going to do this, I need to provide a whole lot more power than just that, than what we've got with 2 little light bulbs. I might not post this. Take care.